Alright, so 8A.2 today we're going to be graphing exponential functions. So I'm going to give you different exponential functions and we're going to graph them using a t-chart, so it won't be too bad. But let me give you some definitions first. An exponential function is the function defined by y equals b to the power of x, and it is called an exponential function with a base b. So b is going to be a number, and your x is going to be in the exponent this time. That's what we call an exponential function. We have two requirements for exponential functions for the base. The base can never equal 0, so b cannot be, equal to 1, and the base must be positive, so it must be greater than 0. And a good example of that would be y equals 3 to the power of x. Okay, guys, so let's actually graph that one, y equals 3 to the power of x. So what I want you all to do is draw a t-chart, an xy t-chart. The nice thing about graphing these exponential functions is that we're always going to plug in the same x's, 2, 1, 0, negative 1, negative 2. So we're always going to plug in the same x values to spit out a y. Draw a coordinate plane for me. Okay, so let's plug in the x's that we chose. If I plug in 2 for x, that's going to be 3 to the second power, which comes out to what? 9, thank you. Okay, and you're just going to keep doing that for all of those values. So if x equals 1, that's 3 to the first power, which is 3. If x equals 0, that's 3 to the 0, and anything to the 0 is always 1. Now, when I start getting into the negatives, remember, this is 3 to the negative 1. What does a negative exponent mean?
Reciprocal.
Reciprocal. So 3 to the negative 1 is going to give me 1 over 3. And 3 to the negative 2 is going to give me 1 over 9. Isn't that interesting? 9, 3, 1, 1/3, 1 over 9. So you just start taking the reciprocal of the others. So to graph this, we're just going to graph it the same, x comma y. So 2, 9 is your first point, so we're going to go right 2 and up 9 spaces. 1, 3 is your next one, so you're going to go right 1 and up 1, 2, 3. 0, 1. Now the fractions is where it gets, you have to be a little good with your estimation. The next one is negative 1, so you're going to go left 1 and then 1/3. 1/3 is not quite halfway, so you're going to go not quite halfway up. So it's going to be close to the x-axis. And then your last one, negative 2, 1/9. That's still really close to the x-axis, but is it actually touching the x-axis? No. And in fact, an exponential function never touches the x-axis. So it will get infinitely close, like 1 over 1,000, but it never actually touches, okay? So the way we would draw these is we get really, really close to the x-axis and then go through all of those points, and it should make a nice curve. But an exponential should never, ever cross the x-axis. And that's your exponential function. They all look like this, either going that way or going the other way. Okay? Any questions? Okay, let's do another one, but this time see what happens if we have a fraction as our base. So this time my base is 1 over 5 to the power of x, but that still satisfies the requirements because it's not equal to 1, but it's still greater than 0. And same thing, we plug in for x, 2, 1, 0, negative 1, negative 2, and then we see what happens. So if I'm taking 1/5 and squaring it, what's that going to give me, guys? 1 over 25, good. If I plug in 1 as my exponent, that's 1/5 to the first power, which comes out to 1/5. It just stays the same. What about 0? Anything to the 0 gives you 1. If I have 1/5 to the negative 1 power, I'm going to take the reciprocal. So what does that come out to? 5. And so then 1/5 to the negative 2 should come out to 25. So let's graph this. 1 over 25. So write 2, and then 1 over 25 is a really, really, really small number. So it's going to be really close to the x-axis, but it's not actually touching. 1/1/5 is also close, but not actually touching, and it's a little bit above. 0, 1. -1, positive 5. 1, 2, 3, 4, 5. And then Ryan asked me, how do we graph -2, positive 25? It's going to go off the graph. So just know that it grows really, really, really fast. And then connect all the points. Don't cross the x-axis. And that's your exponential.
So is it every time you have 0, 1?
Yes. If you have just a base to an exponent, 0, 1 will always be your y-intercept. What else do you guys notice about these two graphs? They're opposite. The one that has a base of 3 is going to be going up, and the one that had a base of 1/5 is going down. It's always going to be that way. So we have two different types of exponential functions. So your exponential functions are either going to look like this. They always go through 0, 1. So they're either going to look like this, or they're going to look like this. We call one increasing and one decreasing. Any ideas as to which one's which?
Decreasing is the one left.
Decreasing is the one on the left, increasing is the one on the right. What I want you to notice that the graphs are smooth curves. So you should be making a nice curve when you graph these, not just connecting them all with straight lines. Okay, so just make sure it's a nice curve. And then I'm going to tell you a little bit about different types of graphs. So, one that looks like this, the one on the left, where it's bigger and then going down, that is called a decreasing graph, and it drops as it goes from left to right. So they drop from left to right. On a decreasing graph, as x gets larger, the graph gets closer to the x-axis, which should make sense. As you're moving towards the right where the x's are bigger, your graph is getting closer and closer and closer to that axis. Okay, that's why it's called a decreasing graph. Okay, exactly the opposite of it, the one that's getting bigger as we go along, is called increasing, if the graph rises as it goes from left to right. On increasing, or we also call them growth graphs, as x gets larger, so as we move to the right, the graph gets further from the x-axis. So as x gets bigger, your graph gets bigger or further from the x-axis. Something I also want you guys to be aware of is on a decreasing graph, your graph is decreasing if your base is a fraction. So if your base is a fraction, your graph is going to be decreasing, which we saw when we graphed 1/5 to the x. So an increasing, we could tell from the equation if it's increasing if your base is a whole number. That's greater than 1. Just a whole number will work. Okay, guys, so if the equation y equals 5 to the x is graphed, which of the following, and this is the important part, values of x, so we're looking at the x-axis here, would produce a point closest to the x-axis? So based on the information I just gave you, my base is a 5. So is my graph going to be increasing or decreasing? Increasing. So just sketch the graph that's increasing. You don't even have to plug in all of the points. Just sketch it. We know it goes through 0, 1. And then if it's increasing, that means it gets bigger. Okay, so just sketch it. It doesn't have to be perfect. But then let's look at what the question is asking again. Which of the following values of x, so remember we're looking at the x-axis, would produce a point closest to the x-axis. When is my graph getting closer to the x-axis? Is it getting closer as my x's get smaller to the left, or is it getting closer as my x's get bigger? Smaller, because it's decreasing, or I'm sorry, well, it's getting closer as we go to the left, right? So which of these x values is the smallest? -1. So that would be your answer. All you're looking for is the smallest in this case. Okay? So you don't have to plug everything in. You can just sketch the graph if it's increasing or decreasing, and you will always either be looking for the smallest number or the biggest number. Okay? So let's do another one like this. This time, like I said, you don't have to write the entire problem, but I'm giving you this equation, y equals 1/3 to the x, so make sure you write that. And the same question, which of the following values of x would produce a point closest to the x-axis? Okay? Since the base of this one is a 1/3, is this going to be an increasing or a decreasing graph?
Decreasing.
Decreasing. So it goes through 0, 1. Make it decreasing. Like I said, it doesn't have to be perfect. Okay, and we're looking at where the graph is getting closer to the x-axis. So as I'm going to the right, my graph is getting closer to the x-axis, right? So going to the right, is that where x's are bigger or is that where x's are smaller? They're getting bigger. So of these three answers, which one is the biggest? 7/4. Because you can actually change that to a mixed number, 1 and 3/4, which is definitely bigger than 2/3, right? That I was just about to get to. Why does the base have restrictions? Ryan wanted to know why the base cannot equal 1. So if the base was equal to 1, that would be y equals 1 to the power of x, but 1 to any power is always going to be what? 1, right? Because you're just multiplying 1 by itself. So that's going to be y equals 1. So you would just get a constant line if y was, or if your base is equal to 1, which is definitely not an exponential function. What about why can the base not equal 0? So if we let the base equal 0, 0 to any power is always going to give me 0, and actually 0 to the 0 is either 0 or it's 1. We don't know which one it is. So we would end up with the same kind of thing, a constant function through the x-axis. So that's why we have restrictions. If your base is 0 or if your base is 1, you just have a constant function that's a straight line, which is not an exponential. Okay, so that's why our base has restrictions. So just remember that the base must never be 0 or negative. Okay? So if you ever get a function where you have a 0, 1, or a negative number as your base, stop. Okay? All right, a couple more on this. So I do want you to write this one down. Which multiple choice ordered pair represents the y-intercept of the function y equals 2 to the power of x? Okay, so it's asking me for the y-intercept. If I'm looking for the y-intercept, what would I plug in for x? You guys remember? Your y-intercept is where x equals 0. So all you're going to do is plug in 0 for x. So y equals 2 to the 0, which comes out to what? 1. So what would our y-intercept be? 0, 1. So B. Okay. We did already ask this, is my y-intercept always 0, 1? As long as there's nothing being added or subtracted to the back of your function, it will always be 0, 1. Okay. Okay. Similar question. The graph of y equals 1/10 to the power of x contains which of these points? And I give you 0, 0, 0, 1, 0, 10, or 0, 1/10. What do you guys notice about all of our answer choices? X is always 0. So any ideas of how we could easily figure this out? Plug in 0 for x. Every single one has x equals 0. So let's just plug in 0 for x and see what we get. Anything to the power of 0 always gives me what? 1. So what would my answer be? C, 0, 1. Also the y-intercept, right? Okay, so just asking you the same question in a different way.